Lesson 8.1, you're going to be introduced to two vocabulary terms called the angle of elevation and angle of depression. What this simply means is that given a certain spot where you always start at 0 degrees, if something is above that 0 degree mark, then what we are looking at is what we call the angle of elevation. The angle that's formed with the 0 degree mark would be the angle of elevation. It's being elevated or raised, and so that's why that position is above that 0 degree mark. However, if something goes below the 0 degree mark, so now the angle is going in the clockwise direction, and that angle is now formed in the lower part, then this angle right here is called the angle of depression, where depression just means going down. Okay, so that angle is going down. So those are two vocabulary terms you're going to need. For example, as we take a look at example 2 here on the first page of 8.1, we see that Michelle's eyes are at 5.5 feet tall. She measures the angle from the horizontal to the top of the gym. So if you can imagine, here is Michelle's eyes. Right? So here's Michelle's eyes, and there's Michelle. And then she sees the top of the gym right here, and we see that the angle of elevation is at 52 degrees. Okay, so just imagine something like that. And so you have the gym here, right? This is the entire building here. Also notice that Michelle's eyes, one characteristic that they give is that the eyes are at 5.5 feet tall. So make sure you consider that when finishing off this problem here. For example 3, a lighthouse keeper observes a 3-degree angle, and actually there should actually be of depression there. So we're actually going to be looking at the angle of depression, comparing it versus number 2. And so, if you picture a lighthouse, here's my best attempt at a lighthouse here, right? Here's the lighthouse. And, it's looking out to sea, so here's the water, right? And from the lighthouse, you always have that 0 degree mark, but now it sees a ship that is being formed through its angle of depression. So if you just imagine that, we're creating a 3-degree angle of depression, and then right there is going to be our ship, something like that. Okay, so just use those kind of diagrams there to help you in answering those questions. What I really recommend for 8.1, whenever you're dealing with real-life word problems, or just any problems at all, if you can draw a picture will go a long way. A picture will help you understand just visually what should you be seeing, and just be able to put all your thoughts on paper. So for a lot of these problems, for most of these problems actually, I really recommend drawing the picture, draw the triangles, and be able to label all the parts of the triangles. Okay. So a couple of problems that I probably think you might have some difficulty with. I'm just going to go ahead and work out with you here. So let's take a look at example 5. What we want to do is find the value of h and x. Now you'll notice that there's actually 2 triangles, I guess maybe even 3 triangles that you see here, but really what we're going to focus on are properties of triangles that we know, which in this case would be right triangles. Okay, so in this particular drawing here, what stands out to me is that we have a right triangle kind of in this spot right there, and you'll notice it does have a 35-degree angle there. So if I were to think of the parts that are assigned to this particular triangle, the only thing I can really come up with is the understanding that the tangent of 35 degrees is the same as opposite over adjacent. So I can create this trig ratio here, h over x. Now as I take a look at the other triangle, I really can't do much with an obtuse triangle because we really haven't learned much about that just yet. But what we do see here is that same hypotenuse can still form an even bigger right triangle right there. And that angle still has the 33-degree angle there. If I think about the parts of this particular triangle, what I see is that I can still develop a tangent ratio. I have tangent of 33 degrees now, which will equal opposite, which is still h, right? Opposite of 33 is still h. And now adjacent is actually going to be comprised of this entire line segment, which in this case is going to be x plus 8. Okay, so what I've now developed is 2 trig ratios, and from here it looks like I almost have like a system of equations. So maybe what I want to do is maybe just isolate a variable. Let's say that h is equal to x tangent of 35 degrees. And then from there, maybe I can actually just plug in this x tangent 35 into this h. It's just a system of equations, right? So if we go ahead and solve that, then we get tangent of 33 degrees is equal to x tangent 35 degrees over x plus 8. Because I'm trying to solve for x, the problem is that there's an x on the numerator and denominator. So what I want to do is be able to have them both as a numerator. So in order to do so, what I need to do is just actually move the x plus 8 over. So what we'll have is x plus 8 times tangent 33 degrees is equal to x tangent 35 degrees. And at this point, what I'm trying to do here is isolate the x, right? I'm just trying to get the x by itself. So I guess one thing I could do is I could just divide both sides by tangent 33 degrees, right? And in doing so, we'll get x plus 8. That's all on the left side is equal to x. And then really keep in mind that tangent 35 degrees is just a number, and tangent 33 degrees is also just a number. So really this is almost like a coefficient of the value of x that we have on the right side. Okay, so if that's the case, I guess we can actually just combine our x's together, right? We're gonna, let's bring our x's together. I'll just subtract x on both sides. This will bring me over here. And so what we have now is 8 is equal to x tangent 35 degrees over tangent 33 degrees minus x. And from here, okay, this is really like saying, okay, if this is a number, if it's a coefficient, it's almost like saying, let's have like 3x minus 1x, something like that, right? Of course it's not 3, but that's the idea. And if that's the case, well, if I have 3x minus 1x, you know, because it's not necessarily 3, what I could do is make my life easier and just factor out the x, and maybe this can just become our coefficient, right? It's just the number. So let's go ahead and do that. Let's actually factor out the x, and what we're left with then is tangent 35 degrees over tangent 33 degrees minus 1. And that's equal to 8. One last step, we really just want to solve for x, so we just divide both sides by tangent 35 over tangent 33 minus 1 on both sides. Just like that. And that'll give us our value. And so at this point, we just plug into our calculator. Okay. Let's go ahead and get our calculator open. All right, so if I recall correctly, what we're doing is 8 divided by, and then we need to have a parentheses. Remember, your calculator should be in degree mode, so just, I'm kind of toggling it on and off because I can't really show it, but you can see here I want to make sure my calculator is in degree mode. And what I want to now do is I'm entering the degree value, so tangent of 35 degrees, 35, divided by tangent 33. Remember, this is in degree mode here. And then I'm going to move on over and subtract 1. There we go. And does that look right? I think that's everything that we needed, right? So we get 102 let's say 27 degrees. Okay, so 102.27 degrees is going to be our answer. Oh, sorry, not degrees. I'm sorry. That's not a degree symbol. The x value, what was that giving us? The x value was a length, right? So in this case, you'll notice that we have 8 feet, so we're just going to keep it as feet. So 127.27 feet is the value of x. Now the question was asking not only for x, but also for h. So now we just go ahead and plug in, why don't we plug it into our more basic tangent equation right there. So tangent 35 is equal to h over 102.27. So we're going to take that value, multiply by tangent of 35 basically. So take this value, multiply it by tangent 35, and we get a value of 71.61. 71.61. Okay, so h is 71.61, and again, this is in feet. There we go. Okay, so that's number 5. Let's take a look at number 6. Draw a triangle KLM with M being 90 degrees. Okay, so I'm just going to draw a right triangle, and this is going to be our M. And then at this point, I guess it doesn't really matter. Let's call this K and L. And what it says is tangent of K is 1/4. So if this is K, we know that tangent is really the same thing as opposite over adjacent. So opposite 1 and adjacent 4, we can just give it the ratio of 1 to 4 like that. And therefore, what we want to do is find sine of k and cosine of L. Well, we know sine and cosine require us to get a hypotenuse. So at this point, let's go ahead and find out what this hypotenuse is then. Okay, so we got 4 squared plus 1 squared equals c squared. 16 and 1 give us 17, so c is going to equal the square root of 17. That's the value there. And therefore, so to answer part A, sine of k is simply going to be opposite over hypotenuse, or rationalizing that, we get root 17 over 17. And cosine of L, that'll give us, here's L, so adjacent over hypotenuse will give us 1 over root 17 again, and so we get root 17 over 17. Okay, all right, part B. Given that tangent of k is equal to x, find sine of k in terms of x. Okay, so now we know that tangent of k is equal to x. Let's see here. Well, we know that if we want to find sine of k, well, we do know that tangent is the same as sine over cosine. So why don't we split that up? Sine k over cosine k is equal to x. So therefore, sine of k is equal to x times cosine k, just like that. Okay, and cosine of k, we can see that is the value of 4 over root 17, because that would be adjacent over hypotenuse. So sine of k is equal to x times 4 over root 17. Okay, and there we go. Sine of k is in terms of x. Notice how k is in terms of x, right? And so just simplifying this, sine of k is equal to 4x root 17 over 17 once we rationalize it, just like that. Okay. All right, one last problem that we'll do together, and that'll conclude our 8.1. Everything else you'll do in class. So find x and y in terms of alpha, beta, and a. So let's go ahead and do that. Now, as I look at this problem, I do notice that there's two triangles here. They both share a common side. Let's go ahead and call that h. I think that's what we'll need. We'll need to figure out how we can use that h value, because that's what they share in common. I'm going to write a couple things down just based on just some understanding of some of these angles here. I know that if I look at that alpha symbol, I know that cosine of alpha is the same as x over y, right? Find x and y. So we want to find x and y. Let's see what else. I'm just trying to come up with some other ratios here. I know that sine of beta, I can only do sine of beta because those are the only two things that I'm given. I don't necessarily know that this is x, right? It's not a parallelogram per se. So I don't know what this is here. So all I know is h and a. So I can say sine of beta is h over a. That would lead me to believe, since I want to use that h is the same as a sine beta. Let's see here, what else can we do? Why don't we try sine of alpha too? Sine of alpha is h over y. There we go. Let's use that h value that we have there, and we're going to plug that into this h value here, right? And that way we'll get our y. Our y is the only thing that's here, and everything will be in terms of beta, a, and alpha, just like the question is asking us for. Y wants it in terms of a, beta, and alpha. Okay, so that's the idea there. So let's go ahead and do that. So we'll say sine of alpha is equal to, let's bring the y over. So y sine alpha is equal to h, and therefore y is equal to h over sine alpha. What's h? H is just a sine beta, and that's going to be over now sine of alpha. There we go. Okay, so you can leave your answer like that. If you want to be a little bit more clever, you can also say that this is the same as a sine beta, and since you have over sine alpha, remember that's really the same as a cosecant of alpha as well. So you can be a little bit more clever and say your answer has a cosecant in it as well. Okay. Let's see, we also need to find x. So let's think about how we can get x here. If I wanted to utilize x, maybe I should use something like this, right? Because we don't want to use the y. We want the x in terms of everything else, not the y. So let's go ahead and see that, in terms of a trig ratio here, it looks like I'd want to use a tangent. So tangent of alpha is equal to h over x, and therefore x tangent alpha is equal to h. So x is equal to h over tangent alpha. And we said what h was already, right? H is the same as a sine beta, oops, a sine beta over tangent alpha. I'm running out of space here, and I can't move this paper anymore. Okay, so I guess, you can leave your answer like that. That works. Or again, if you want to be a little bit more clever, you can say that technically 1 over tangent is cotangent, right? So we can say that x is also equivalent to a sine beta cotangent alpha. So that's another way you can say your answer. Okay? All right, that'll conclude 8.1, and the rest we'll do in class.